Let's look at a few more examples of recurrence relations. So let's suppose I'm looking at two sequences, A1, A2, A3. So that's one sequence, and B1, B2, B3. That'll be another sequence, and they satisfy the recurrence relation for every integer k greater than or equal to 2. AK will be 3 times AK minus 1, and BK will be 3 times B to the K minus 1. And I need to give you some initial conditions. With initial conditions, A1 is 2 and B1 is 1. So if you look at these two sequences, they have the same recurrence relation right here for A and B. Those equations are exactly the same, but if I look at the initial conditions, they're not the same. Okay? So what I want us to do is find the following. Let's find A2, A3, and A4 first. So we're going to use our recurrence relation formula. A2 would be 3 times A1. So 3A1 from our initial condition is 2. So A2 is 6. Again, use our recurrence relation to get A3. It would be 3 times A2. 3 times 6, 18. And now let's find A4. 3 times A3, 3 times 18, or 54. So now, let's repeat this, but now do it for the other sequence. So I want you to find B2, B3, and B4. So B2, again using our recurrence relation for B now, it would be 3 times B1, but B1 was 1, so this will be 3. B3 would be 3B2, or 9, and B4 would be 3B3. 3 times 9 is 27. So if you compare these two sequences, they had the same recurrence relation, but if I look at these numbers in their sequence, they're not the same. So the key idea here is that the initial conditions were different for these two sequences. So it's not enough to just have the recurrence relation. You also need to have the initial conditions. Okay. So now we're going to look at one more example here, and it's one of the most famous sequences. Is the sequence of Catalan numbers It can be defined as follows. For each n greater than or equal to 1, Cn would be 1 over n plus 1 times 2n, choose n. So I'll just remind you of this formula we saw previously. Recall that this formula for integers, n and r, and they need to be positive. R needs to be less than or equal to n. N choose r. Has this really nice formula, n factorial over r factorial, n minus r factorial. So one thing I want to mention is that this formula right here, this is not a recurrence relation. It's an explicit formula for the Catalan numbers. So let's use this explicit formula here to find, let's find C1, C2, and C3. So let's start with C1. C1, if I plug in 1 in place of n in this equation up here, I'm going to get 1/2. 2 choose 1. So 1/2 times 2 factorial over 1 factorial times 1 factorial. So this will be 1/2 times 2, or 1. That's my first Catalan number. Now let's look at C2. Go back to your formula and plug in n equals 2 into it, so you'll get 1/3, and you'll get 4 choose 2. 1/3 times 4 factorial over 2 factorial times 2 factorial. And if you simplify all that, you should get 2. Let's find C3 now. Again, you're going to plug in n equals 3 into the formula. 1/4, 6 choose 3. 1/4 times 6 factorial over 3 factorial times 3 factorial. And if you simplify all that, you should get 5. So one thing you might notice is that this formula involves these combinations, choosing, which means I have to use factorials here in my calculations. And so instead, it might be helpful if we look at a recurrence relation for this. So the sequence of Catalan numbers also satisfies the relation C sub k equals 4k minus 2 over k plus 1 times the previous Catalan number. And so this right here, this is a recurrence relation. Because each term depends on the one that came before it. Okay, and this formula is, while it is a recurrence relation, it's a little bit nicer of a formula because you don't have the combinations and you don't have factorials appearing.